morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic, we are discussing about what kind of technique gives the better enhancement or required enhancement, desired and properties for the project. So, in that, this is one more case study here we are going to understand in this particular lecture, that is soil stabilization. The required thing is soil stabilization using lime. So in this particular thing, in the project requirement, what stabilization is required for the soil, but the stabilization is not up to the requirement of the project requirement. In that particular condition, we adopted the lime technique for getting the ground improvement techniques. In such type of conditions, case studies, we observe what are the various parameters which are involved in that particular thing and what are the various influences are there in that particular. These are all the parameters which are influenced in this particular stabilization, soil stabilization using this lime. So in this particular case study, we have to observe all those things. What are the characteristics? What we have to understand in this particular thing. In this introduction to soil stabilization is a process to improve physical properties of soil. So, what is the soil stabilization? It is nothing but to improve the physical properties of soil such as strength, durability, and load bearing capacity. These are the properties, these are the some of the physical properties which are going to improve using the soil stabilization. In this soil stabilization, we have different kinds of techniques. In this particular case, we choose lime as our technique, ground improvement technique we choose. So, in this particular case, the ground improvement technique is lime. So, here, according to, as per civil engineering point of view, essential for enhancing subgrade properties, particularly for large infrastructure projects like highways, tunnels, underground structures or underground elements, for to support the heavy loads, So this is the why civil engineering is, what is the civil engineering importance in the soil stabilization, for what kind of properties we are going to enhance for getting the desired project requirements using such any kind of technique. So we will observe in this particular case study soil stabilization by using lime. So in this, the particular case study, what we consider in this particular case study, that is NH8 Delhi to Jaipur highway project. So in this NH8 Delhi to Jaipur highway project, in this the project background, NH8 is critical highway connecting Delhi and Jaipur because it facilitating significant commercial and passenger traffic. The project involved widening and strengthening the highway to accommodate increased traffic demand. So already it is going to widening as well as strengthening the highway to accommodate increased traffic demand. Here, what as a civil engineer, what are the challenges which we are going to face and how we are overcome using ground improvement techniques. Because of that, what are the various environmental considerations, some other considerations as per the regularities, as per the laws, legal points we are obey, and we are going to done the construction based on the challenges. So here the challenges are for this particular case study, that is the existing subgrade soil as weak. The existing soil subgrade is there, that is in weak, predominantly consisting of clayey soils with low bearing capacity. Here the soil is in weak condition, already it is existing, and also it is clayey soil. It means clay soil, it means it leads to the low bearing capacity. Low bearing capacity cannot obey the heavy loads, heavy traffic loads. Anyway, national highway means in that roadway so many kind of different heavy vehicles are going to move from export or import purpose. So, but this is have that much this kind of soil not supported for heavy load bearing capacities. It has low bearing capacity. So the soil has high plasticity, and also here one more challenge, that is it has high plasticity and low, it means it leads to the low strength, were unsuitable for planned heavy traffic loads. These are the challenges we are going to face in this Delhi-Jaipur highway project. Since this is the overall view of the project. Now, move on to these. What are the various challenges? Based on these challenges, what are the various solutions? What are the various parameters which are involved in this particular case study? So, we will see. So, in this overall, this is the national highway, and because of the highly demand traffic is increased, due to that we are going to winding and strengthening the existing project. Now the existing subgrade soil is already it is in weak, and that is weak, and also it is clay soil. It means it leads to the low bearing capacity and also high plasticity there. So now we will understand how we overcome these kind of problems by using as ground improvement technique point of view, and also few more environmental concerns. Here, why lime stabilization? Here already we decided, the heading itself tells us we choose lime. So it is nothing but the lime stabilization. So we choose lime stabilization, soil stabilization. Here, lime we are considered as a stabilizer. It is a stabilizing agent for clayey soils. Different soils has their own different kind of stabilizations. Here lime is for clayey soils because it reacts with the minerals in the soil, leading to improved engineering properties. Soil density, already plasticity is there for getting the more not existing bearing capacity, enhanced load bearing capacity. In those perception, in those point of view, we have to understand these engineering properties. So here the lime as a stabilizer, it is a common stabilizing agent for the soil. Here whenever we choose the technique, it depends upon the what type it is, because it is lime and it is suitable for clayey type of soil. Other technique may other kind of type of soil. So now advantages for this, it is cost effective, it improves soil properties and also environmental benefits. Here, why cost effective means when compared to the other stabilizers, lime is relatively inexpensive and widely available. It is, the availability is also important for choosing the stabilizer. For choosing stabilizer, availability is also important. Here the lime is relatively available as well as it is inexpensive. It is inexpensive as well as it is widely available. In this, lime treatment enhances the soil strength, reduces plasticity and increase durability. So these are the parameters, these are the modifications we will understand These are the engineering properties modifications by using lime as stabilization. Those are in strength point of view, it increases its strength. Plasticity, it reduces the plasticity. So that's why not it comes under all properties point of view, it is not going to increase. Some may reduce, but we need the modification of that particular property and increase its durability. In environmental benefits, lime stabilization is sustainable method and it uses as a natural material and can reduce the need for expensive and environmentally harmful soil replacement. So whenever we are using chemicals, we have those kind of concerns are required because those chemicals may affect the environment and in soil point of view also, in any nearby water is there, so in so many ways it is may affect. So in that point of view, lime, it is a natural material. Lime stabilization is a sustainable method. Why? Because it uses a natural material and reduce the need for expensive and environmentally harmful soil replacement. So these are the advantages once we choose this lime stabilization. And in this, what are the chemicals, what are the various reactions which are involved in this lime is, so in this cation exchange, pozzolanic reactions are involved in this lime. So lime is mixed with clayey soil. The calcium ions, those are Ca2 plus. From lime replace the sodium, that is Na plus, and potassium ions in the clay minerals. This process reduces the soil plasticity, makes the soil more variable. So because of these, what are the chemicals which are involved, what are the ions, what are the various things which are involved in this lime, in the two clayey soil, the calcium ions from lime replace with the sodium and potassium ions in the clay minerals. The process reduces soil plasticity and makes the soil more friable. In pozzolanic reaction, over the time, not immediate, over time, lime reacts with silica and alumina in the soil to form calcium silicate hydrate. Calcium silicate hydrate, because lime reacts with silica and alumina. So in this soil form calcium CSH and calcium aluminium hydrate CaH, calcium aluminium hydrates, which are responsible for increased strength and durability of the soil. So those are responsible for increased strength and durability of the soil. So these are the reactions which are involved in this lime stabilization. Phases of lime stabilization. Initial short-term effects, long-term effects are there in lime stabilization. The immediate improvement in workability and reduction in plasticity. In long-term strength gain, over weeks to months, pozzolanic reactions results in significant shear strength gains, making the soil suitable for supporting heavy loads. These are the phases which are involved in lime stabilization. In immediate improvement in workability and reduction in plasticity is the one of the phase which you are observed using this lime as a stabilizer. In long-term strength gain over weeks to months, whenever based on these pozzolanic reactions, because of cation exchange, those ions exchanging, the immediate reduction in plasticity we will see in the phase of lime stabilization. In coming to the pozzolanic reaction over time to time, because of these CSH and CAH, the result in significant strength gains, making the soil suitable for supporting heavy loads. So this is the chemistry which involve in lime stabilization. In this process of stabilization in NH8 project, the first thing, whatever it may be, we have to assess and we have to understand, we have done the site preparation in any kind of project it is. So now the process is start with site preparation. In this site preparation, we are going to assessment and lime quantity determination. These are the parameters we have to understand. Whatever the technique it is, we have to use few any other materials. We are dealing with materials. It means how much the quantity is required. The determination is also the primary step in ground improvement techniques. So in this assessment, the soil was first assessed for its properties. So first we have to understand what are the various soil properties which are involved in this particular thing. So what are the various soil properties which are included in this particular site condition? In that site, what kind of soils are available? Here we know those are clay soils. So that soil type is clay. So after that, what kind of numbers we will get the numerical values for using this soil sample? We will get the plasticity index, moisture content and grain size distribution. First we will assess soil to know about the properties. Now in lime quantity determination based on the various laboratory tests, so we have to understand how much percentage of lime needed for stabilization is you have to calculate. So usually it is ranging from 2% to 8% by weight of the dry soil. So based on the dry soil, this much percentage of lime quantity we are going to determine based on that particular. It is depend. Every time same kind of percentage of lime quantity we are not going to use in for all kind of projects. It depends upon the type of the project. And also soil properties. It means required properties and existing properties. It means type of soil. So depends. It depends between these two. So like that we start our process for the site preparation. Now this application process, now mixing. Lime was spread uniformly over the prepared soil surface. So now we are going to spread uniformly over the prepared soil surface. A rotor or disc harrow was used to mix the lime thoroughly into the soil. In this moisture addition, water was added to the soil lime mix to facilitate the chemical reactions and to achieve the desired compaction moisture content. So here water was added to the soil lime mix to facilitate the chemical reactions and to achieve the desired compaction moisture content. Here this compaction, the soil lime mixture was compacted using rollers to achieve maximum density. So proper compaction is critical for ensuring the long-term performance of the stabilized soil. So the mixture, whenever you are using these rollers to achieve maximum density, so this is very critical, which ensuring the long-term performance of the stabilized soil. Long-term performance of the stabilized soil. Now here these are the procedure. First we have to prepare the site preparation. We are going to assess how much lime quantity is required. In application process we are going to mix. Any moisture addition is required and move on to the compaction. Now curing. The compacted soil was left to cure. Curing is essential for the pozzolanic reactions to occur, leading to increased soil strength over the time. So this curing, whenever we are use this curing, the compacted soil was left to cure. It is essential for pozzolanic reactions to occur. So in pozzolanic reactions, already we discussed in over weeks to months, in over time. So because of these pozzolanic reactions to occur lead to increased soil strength over the time. Further, this step is involved. So first we have to understand the site preparation based on the assessment and lime quantity determination. application process. Now mixing is done. We have to uniformly spread. Any moisture addition is required, and also done the compaction. It is important for the getting the stabilized of the soil. Because of the pozzolanic reactions, the curing step is also lead to increased soil strength over the time. So here what kind of equipment we are using for this lime stabilization process? Rotavator for mixing lime into the soil, disc harrow to break up and mix the soil lime blend, water tanker for adding moisture to the mix, compactor roller for compacting the stabilized soil to desired density. For getting the desired property, we are going to choose all these equipment. So for proper mixing, for this process, these are the various equipment we are used for their different uses. Now, in this performance evaluation, these are the testing parameters. Those are unconfined compressive strength, that is UCS, CBR, and plasticity index, field monitoring. In these test parameters, UCS tests were conducted on samples taken from the stabilized soil to assess the increase in the soil strength. So for understanding about the soil strength, we are going to conduct these unconfined compressive strength. For understanding about the soil strength taken from the stabilized soil sample. These test parameters for understanding the performance of the soil. And the CBR test was performed to evaluate the improvement in load bearing capacity. Once the soil stabilization is done, we are going this load bearing capacity, and we are going to perform these tests to evaluate about and how much improvement in this load bearing capacity. And the plasticity index, reduction in plasticity index was monitored to confirm the effectiveness of the lime treatment. So in this, the reduction in plasticity index was monitored to confirm the effectiveness of the lime treatment. In field monitoring, continuous field monitoring was carried out to ensure that the stabilization process meet the design specification. Here, so those continuous field monitoring was carried out to ensure that the stabilization process meet the design specifications. These are the performance evaluation. So now, why lime stabilization? And what are the reactions that are involved? What are the phases? What is the process we will follow, and which kind of equipment we are using? How the performance analysis using their test parameters. And in this, what are the various challenges and their solutions in this lime stabilization process? This moisture control is the one of the challenge, and also uniform mixing. These are the major challenges which we observe in this. So now, this ensuring the correct moisture content during the mixing and compaction was crucial. Excessive moisture could lead to poor compaction, while insufficient moisture could slow down the pozzolanic reactions. Here, strict monitoring and controlled water addition during the mixing process. Here, we are ensuring the correct moisture content during the mixing and compaction. So, how much content we are considering in that during the mixing process and compaction, as we consider as that is crucial. Excessive moisture could lead to the poor compaction, while insufficient moisture could slow down the pozzolanic reaction. So, excessive also lead to the compaction is less, insufficient also could be slow down the pozzolanic reactions. Once slow down the pozzolanic reactions, it leads to reduces the strength. As well as expansive, the proper compaction was not done. So in that particular, the solution is strict monitoring and controlled Water addition during the mixing process is important. Strict monitoring and water control addition during the mixing process is very, very important. The strict and uniform mixing. So achieving a uniform mix of soil and lime was challenging, especially over large areas. Whenever the small area is there, it's not an issue. We make sure that it's okay for uniform mixing will be done. But coming to the large areas, so multiple passes with mixing equipment and use advanced machinery for consistent mixing. So this is important. These are the challenges and the solutions which we are going to face. These are the challenges those we are going to face in our lime stabilization process. In this, environmental and sustainability consideration, reduction material use, dust control, long-term durability. In this environmental and sustainability considerations, lime stabilization allowed reduction material use. So lime, the usage of lime is more in so many aspects. As a civil engineer, we may understand in cement preparation also we are using so many in so many aspects we are using this lime. So using this, it is going to reduce and it affects the environmental. It affects the environment. The sustainability is not going. So that's why we may reduce the need for importing new materials and thus lowering the environmental impact. So because the lime we are using in so many aspects, cement is best example for civil engineers. So this is leading to the environmental impact. Now the dust control. During lime application, dust generation was controlled to minimize the air quality impacts. And long-term durability. The increased durability of stabilized soil reduced the need for frequent repairs, contributing to the sustainability for highway infrastructure. These are the considerations which we are going to understand in this environmental as well as sustainability considerations. In this, in ground improvement point of view, this expansion of these NH8 and Delhi Jaipur highway, it refers various techniques used to enhance the physical properties of the soil to meet engineering requirements for construction projects. So we have n different kinds of techniques to choose. And also for getting properties also in this, based on the best practice, we are choosing the technique. Now, in this importance essential for infrastructure projects built on weak or problematic soil, ensuring stability, durability and safety of structure. These common techniques: lime stabilization, cement stabilization, dynamic compaction, stone columns, geotextiles and soil mixing are the various techniques which we are used to get the desired properties of this soil for project requirements. In this, the project overall view, the significance. So it is a major highway connecting from Delhi to Jaipur. Critical for economic activities in the region. The expansion was needed to accommodate the increased traffic and support higher loads. And the site conditions, the highway traverses regions with very fine soil condition, including clayey soils with low bearing capacity, requiring the ground improvement technique. We choose for this pre-stabilization activities the groundwork, the site investigation to assess the soil conditions, determine the suitability of the existing subgrade for the construction. Here, soil sampling, geotechnical tests, in situ tests which we are conducted. In soil sampling, boreholes and test pits were dug along the highway to collect the soil sample for laboratory testing. So after collecting the samples, we are going to conduct the test for understanding about the soil properties. Once we understanding the soil properties, then only we know the desired properties of the soil, required properties of the project. We know the project requirements. Soil properties and the laboratory tests. So we know based on the samples we conduct the test, we know the soil properties. According to the requirements we choose the which technique gives the better results. So for that purpose and also understanding this, we have done the soil sampling. Now geotechnical tests. Tests including particle size distribution, Atterberg limits, moisture content and soil classification. In situ testing, standard penetration test and cone penetration test were conducted to assess the soil strength and compressibility. For getting what kind of property and what kind of test we are going to conduct, it depends upon the property. Based on that, we are conducting the sample test. Now, in these soil characteristics are clayey soils, high plasticity, low shear strength, poor drainage. These are the soil characteristics. That is clayey soils, high plasticity, low shear strength, poor drainage. These are the things which we are going to understand in this soil characteristics after conducting the test. So here clayey soils means in the project area, high plasticity makes the soil prone to swelling and shrinkage with moisture changes. It means it is going to change, moisture changes will happen whether it is swelling and shrinkage because of the high plasticity. And low shear strength means because of the heavy traffic load it is not supportive. Not supporting heavy loads. And the poor drainage tends to retain water leading to the long-term settlement issues. These are the things which we are going to understand in this based on the test we conducted. And design considerations in this: load-bearing requirements, longevity and durability, environmental impact. In load-bearing requirements, the highway needed to support heavy vehicular loads. So it is having to, in these heavy loads are going to, for bearing, it requires load-bearing capacity. It requires load-bearing capacity. Longevity and durability, the ground improvement method has ensured to long-term stability with minimal maintenance. Environmental impact, the selected technique needed to suitable and environmental friendly, minimizing the disturbance to the surrounding area. These are the design considerations. And after these ground improvement techniques, what we consider those evaluation options are lime stabilization and other techniques considered, that is lime stabilization, cement stabilization, geotextiles and dynamic compactions are the options. We have to choose one for this kind of scenario which we have as a case study. So now we have to choose. We have the options, that is lime stabilization and cement stabilization and geotextiles. Ground improvement technique we may use dynamic compaction. These are the options we have. According to these options, we have to choose one as per the assessment of this. So lime stabilization is chosen for its effectiveness in improving the properties of clayey soils. In cement, why we are not choose cement stabilization technique for this kind of existing NH widening and strengthening? It is more costly because of this cement and also its other material, and it is less suitable for highly plastic clay form. So this kind of technique is not suitable high plasticity clays. And also geotechnysis is also one more technique which we use, that is using in conjunction with other methods but not as primary solution due to the soil type. Dynamic compaction not suitable for soft and cohesive soils in this process. So these are the parameters, that's why we choose this lime stabilization. And in this lime stabilization, what are the detailed ground improvement process it is, that is what kind of lime type, the lime selection and mixing. This lime type, quick lime, that is calcium oxide or hydrated lime, calcium hydroxide, was selected based on availability and soil chemistry. In this, the mix design, lime content, laboratory test determine the optimal lime content, typically between 3 to 8 by weight of the dry soil. It depends upon the soil conditions and desired properties, how much percentage we have to pick. This mixing process, lime was spread over the soil surface, thoroughly mixing with using mechanical equipment such as rotovators. In moisture content, controlled addition of water to achieve the necessary moisture level for effective chemical reactions and compaction. These are the steps which are involved in mix design. In this compaction and curing, these compaction equipment, rollers and compactors were used to achieve maximum density of the lime soil mixture. And also the curing period, the stabilized soil was allowed to cure within a minimum of 7 days to allow pozzolanic reactions to take place, leading to strength gain. So like this, we are going to understand what are the various parameters involved in this, and compaction and curing, which kind of equipment gives the what kind of reaction. In these are the things, this compaction and curing. And field controlled and monitoring. Now quality control, field density tests and moisture control. After post-stabilization, unconfined compressive strength, California bearing ratio, that is CBR, permeability tests are conducted. As a part of quality control, field density tests to ensure the compacted soil meet design specifications or not, as a part of quality control. Now moisture content, continuous monitoring of moisture levels during compaction and curing to optimize the strength development. And post-stabilization testing, unconfined compressive strength UCS, to measure the increase in soil strength. California bearing ratio CBR to assess the improvement in load bearing capacity. Permeability test to assure that the stability soil had reduced permeability, preventing water infiltration that could weaken the structure. So these are the after lime stabilization is done. These tests are required for understanding the whether it is increased the soil strength or not, what kind of load bearing capacity improvements we understand to prevent the infiltration that could weaken the structure. So to ensure soil had reduced permeability. These are the parameters which we are going to understand in this particular thing. And in environmental and sustainable parameters, what kind of environmental impact is done because of this lime stabilization? For getting the desired soil properties. In this, dust control, waste management, energy efficiency. In this dust control, measures were taken to minimize dust generation during the lime application, including the use of water sprays and covering stockpiles. As a part of dust control, we done this and it reduces the environmental impact. And waste management, lime application was managed to avoid waste with the careful handling and storage of materials. This energy efficiency, lime stabilization required less energy compared to the alternative like cement stabilization, make it more suitable choice. In long-term performance, the stabilized soil exhibits improved resistance to environmental factors such as moisture variations and freezing time cycles. In this maintenance, reduced need for further maintenance due to enhanced load-bearing capacity and stability of the subgrade. These are the environmental impacts and their long-term performance. In comparative analysis with other techniques, lime stabilization versus cement stabilization, lime is typically less expensive than cement. Lime is more effective in treating high plasticity clays, whereas cement is preferred for sandy and gravelly soil. So it depends upon the type of soil also. For clay and high plasticity, lime is suitable, whereas sandy or gravelly soils, cement is suitable. In environmental consideration, lime has lower carbon print when compared to the cement, making it more sustainable option. In sustainable point of view, this lime has lower carbon footprint. Coming to the cement, it has more carbon footprint and emissions are there and different kind of effects will happen in environmental consideration point of view. In integration with other techniques, combination with geotextiles, in areas where additional reinforcement needed, geotextiles were used in conjunction with lime stabilization to enhance the soil stability and drainage. Use of PVDs and pre-loading. In particularly problematic areas, prefabricated vertical drains and preloading techniques were considered to accelerate consolidation. So these are the comparative analysis with other techniques. In overall this particular case study, once we understand the summary, the lime stabilization method successfully improved the subgrade soil strength and reduced its plasticity, enabling the NH8 highway to support the intended traffic loads. In this, the project demonstrated the importance of site-specific elevations in selecting appropriate ground improvement techniques. Lime stabilization proved to be a cost-effective and environmentally suitable solution for the NH8 expansion. So, in these conclusions, for understanding the ground improvement techniques, emphasize the need for thorough soil investigation and analysis in determining the best ground improvement method. In lime stabilization effectiveness, highlight the benefits and limitations of lime stabilization, especially in dealing with the high plasticity clayey soils. In environmental and sustainability aspects, encourage students to consider the environmental impacts and long-term performance of different ground improvement techniques. These are the overall conclusion about the ground improvement techniques using limestone for especially expanding the NH8. So according to, we are understanding what are the various parameters involved, what are the various characteristics what we get. These are the things we have to understand in this particular case study. So in further future considerations, innovation in ground improvement as a technology advances as new methods, materials may emerge, offer even better solutions for challenging soils. Integration with modern engineering practices Ground improvement techniques should integrated with other engineering practices such as environmental impact assessments and sustainable construction methods. So thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.